In this Algebra 1 video, we're in Chapter 9, Lesson 5. We're going to talk about solving quadratic equations by using the quadratic formula. Now, before I go anywhere, I've got good news. This is the method that always works. Yeah, that's right, I said it. This is the method that always works for solving any quadratic equation. So now, our objective is, as the student, I can solve quadratic equations with the quadratic formula or just determine how many solutions it has because I will be organized and follow the order of operations. It's that simple. I'm going to give you a formula to use. You just have to plug in carefully, meaning be careful with negatives and parentheses, and just follow the order of operations. Then after that, it's like a recipe every single time. It'll get repetitive and it'll become automatic, and you won't hesitate. It looks scary at first, I hear you, but it's not that bad. So, here it is at the bottom. This is the quadratic formula. But before you can use the quadratic formula, you have to review and make sure you know what the standard form of a quadratic equation looks like. We're going to be using a, b, and c. You need to know that a is the coefficient of x squared, b is the coefficient of x, and c is just a regular number out there chilling by itself. We're going to refer to them by letter, but when I say that, I want you to remember, put them in order, descending order with the exponents. And this is what we're talking about. We talked about this in the polynomial section, but this is an exponent of 2, this is technically an exponent of 1, and technically we can have an x here with an exponent of 0. I'm going off track, but I'm basically just trying to review quickly what standard form is for polynomials. When solving quadratics, we generally are going to set them equal to 0 because we're interested in what are the x-intercepts. And the x-intercepts take place when y is equal to 0. That's why we change the y to a 0. Sometimes you'll see an f of x, but that's the same thing as just saying y. These all mean the same thing. Don't stress if you see a y or an f of x. Anyway, quadratic formula. We're going to plug in carefully into each, I even color-coded each of the corresponding spots for each of those values, and then follow the order of operations. This means plus or minus, meaning there's almost like two questions in there, and I'll show you what I mean when we do some examples, which we're about to do. I'm going to show you some steps to remember, and then we're going to be ready. Here are your steps. These are your steps to using the quadratic formula. You're going to rewrite your equation in standard form if it's not already. So if it's already in standard form, you can skip this step. If it's not in standard form, empty one side of the equal sign so that it's 0 so that it is in standard form. Make sure you can identify a, b, and c. You then use those values for a, b, and c, and you plug them in to their corresponding places. Keep track of if a, b, or c had a negative sign in front of it. Once you plug those in, you're basically just going to carefully follow the order of operations and evaluate. It's that simple. So let's do an example. Just remember, this is the method that always works. That's the good news. Just keep that in mind. So if all the methods to focus on, this would be the one. Let's take this example into consideration. I started color-coded some of it for you, but first thing you should notice is this isn't in standard form. So start by moving this 6 to the other side. It's positive 6, you move it by doing negative 6. So I'm going to rewrite the exact same thing with what we have. So now it's in standard form. So identify a, b, and c. I color-coded them for you. This is a, this is b, and c is negative 6, not positive 6. It's negative 6. That minus sign in front of it goes with it. Just like if there had been a minus sign right here, we would have said b was negative 5. So let's carefully plug those into the quadratic formula. Okay, so let's brought everything to a new page. We're going to plug everything in, be careful, and show our work. Before I jump into this, perspective for a minute. Remember, when you're solving quadratic equations, you're looking for the x values of the x-intercepts, meaning where does it cross the x-axis. So we're looking for x values. You follow this formula, you'll find those x values. Alright, so let's start plugging it in. The formula tells us it's the opposite of b, or in other words, algebraically it's putting a negative in front of b. Well, if b is positive, it's going to become negative 5. If b was already negative, just to make a note, if b was already negative, you'd have negative 5. Now it would be positive 5. That's why we just call it the opposite of b. That tends to make a little bit more sense. So the opposite of b is negative 5. Now keep going, plugging everything in. On the inside of that plus or minus square root, on the inside we have 5 squared minus 4ac, 4 times a times c. Well, a is 1. And c is negative 6. So go ahead and plug those in. Alright, so we're getting there. So just all of it divided by 2a. 2 times a. Now, There's actually a song that I learned to help me remember the quadratic formula. Maybe I'll save it for you at the end of the video so I don't kill you with it. But it's a way to remember the quadratic formula, and to be honest, it helps. It goes to the tune of Pop Goes the Weasel. Alright, so you've plugged everything into the quadratic formula. Now you just need to carefully follow the order of operations to simplify. My personal preference, and I feel it helps students avoid mistakes, is sometimes they make mistakes at this stage. They don't know, is that a -4, is that a +4? And I like to treat it as a -4, but honestly, if you just work your way this way and then include it, that helps. In other words, I would do -6 times 1 first, and that's -6. I would then say, okay, what is -6 times -4? And I would say, okay, that's a negative times a negative, that's a positive, so positive 24, since 6 times 4 is 24. So in other words, all of that becomes plus 24, is basically what I'm saying. That color didn't show up very well. Basically, it becomes plus 24. And then 5 squared is 25. So let's go ahead and write that down, what we're left with on the inside. Remember, 5 squared is 25. We just got done saying -4 times 1 times -6. We just got done saying that was positive 24. So you have positive 24. And on the bottom, you have 2 times 1. Well, that's just 2. Okay, so you're now one step closer. You've taken care of this bit, you've taken care of this bit. Now we're ready to actually combine them. And it turns out becoming addition, because a negative times a negative was a positive. So 25 plus 24. Well, that's 49. So that brings us to our next step. Okay, so we have -5 plus or minus square root of 49 all over 2. Now, this is the part where I'll actually tell you why it's plus or minus. Maybe you remember from last year, or maybe you don't, but let's review for a moment. The square root of 49, I understand you guys realize is 7, but technically it's not just positive 7, technically it's negative 7, because positive 7 squared, 7 times 7 is 49, but negative 7 squared, so negative 7 times negative 7, that's also positive 49, because a negative times a negative is a positive. So the square root of 49 is both positive 7 and negative 7. That's why we have that plus and minus in front, so that you remember there's two questions that this becomes. This value equals -7, but it could also equal positive 7. So we're going to write both versions. So we're going to write both versions where it's plus and where it's minus, and we already said it equals 7. Now, if it was an ugly decimal, like if that hadn't been 49, if that hadn't been a perfect square, if you had asked to take the square root of a non-perfect square, it would be an ugly decimal. And I want you just to round it as precise as you can. Include as many of those numbers after the decimal as you can, because the more precise you are, the less you round, the more precise your answer will be. Notice I wrote both versions, one where it was plus 7, one where it was minus 7. You have two questions at this point. So now just finish evaluating both these following the order of operations, and you're done. -5 plus 7 is positive 2, so we're left with 2 over 2. Well, that equals 1. So one of our solutions is 1. -5 minus 7, well, that's -12, so we're left with -12 over 2. Well, that equals -6. So those are our two solutions. Our two solutions are 1 and -6. X equals -6 and x equals 1. Those are the values of the x-intercepts. Those are the solutions to the quadratic equation. Meaning, if you were to come back to the very beginning and plug in, we said 1 and -6, plug in a 1. If you evaluate that, you're going to get 0. And we said -6. Plug in a -6 for x. And if you evaluate that, you're going to get 0. So they're both going to check out. Those are going to be the solutions that makes this equation equal 0. So that was our first example. So sure, it looked like there was a lot of work to show. It looked kind of intimidating, but I promise you, once you get the hang of it and following the order of operations, it's very repetitive. You'll plug in, you'll evaluate this piece, you'll evaluate this piece, and then you'll combine them, and then you'll take the square root, and then after that step, you will have two questions to answer. You'll have both versions, where it was a plus and where it was a plus and where it was a minus. And after that, you're done. Every single time. It's going to be repetitive. The only thing they're going to throw at you is they're going to give you maybe some ugly decimals in there. And just keep as many of them as you can, round as little as possible, and that'll help you be as precise as possible. And that's to make my point that the quadratic formula always works, even when you have ugly answers, like ugly decimals in between. It'll also find pretty ones too, like we notice here. These are pretty answers. You could have answered this question perhaps with another method we've already learned. Like factoring. This polynomial, this equation actually factored pretty, so you could use the factoring methods we learned last chapter. But that's alright, we'll start off with a simpler one. Now, I know I've only given you one example, but that's basically it. I want you to give this one a shot. Try it on scratch paper if you have to. I'm not going to over-explain this one, but then we'll do a few more examples after this. Give this one a shot, and you try it yourself using the quadratic formula. Alright, so just plug everything. Hopefully you already hit pause. Just plug everything into its spot. Follow the order of operations. So you get everything plugged in. Now follow the order of operations. Negative 4 times 8 is negative 32. Now a negative times a negative, that negative 4 is going to give you a positive answer. It's going to give you a positive 128. So this becomes plus 128. That's what that right piece equals. And 9 squared, well, that's 81. So on the inside we have 81 plus 128. I'm going to get more neat though when I write that. And of course on bottom 2 times 8 is 16. Okay, so now add those together on the inside. You're ready to go on to the next step. Keep going. Now, the square root of 209, that's not going to be a pretty number, so you're going to have a rounded decimal. Just try to be as precise as you can with it. The square root of 209 is 14.456832294800960. It keeps going on forever. That's my point. The square root of a non-perfect square is an irrational number. It's an ugly decimal that goes on forever without a pattern. So basically just write as much of it as you can. So I'm going to estimate and I'm going to call it 14.456. That's probably going to be precise enough to get you there. So now write both versions of that, solve both of them, and you're good. Okay, so write both versions. Now, take no shame in using a calculator for this part. Just be careful and make sure you follow the order of operations. You're careful with those negatives and see what each of these equal. And go ahead and round to the nearest tenth, or the nearest hundred. Just follow the instructions. We'll round to the nearest tenth. So this first one on the left, if you divide that, you can get approximately 0.341, which is about 0.3. So one of your answers is that x equals 0.3. That'll be one of your x-intercepts. Do the same thing for the other one. And the other one comes out to negative 1.466, which is approximately negative 1.5. So there you go. You found your two answers for x. Those are your two solutions to your quadratic equation. Now, technically these are rounded, but the truth is they're ugly, irrational decimals that go on forever. So if you plug in these numbers we have and you go and plug those in, you're going to get something really darn close to 0. They might not equal exactly 0, might equal like 0.0001, but it'll be really darn close. And that's good enough for our purposes of finding it because it's hard to nail down the exact value. And the exact value would be leaving it as the square root, not actually ever doing that part. Alright, so some of you might be thinking, excuse me, in both of these examples that we just did, up here, when we did the square root, it was a positive number. Meaning on the inside we had positive 209. On the inside of this one we had positive 49. So in both those examples we had a positive number inside of there. Well, that's where we're now going to pursue the other possibilities. We're going to pursue what happens when you get a 0 in there, or what happens when you get a negative number in there. That's what we're going to talk about. That's the only other two possible situations when doing the quadratic formula. Before we do that, let's take a moment to talk about what the discriminant is. So that's going to bring me to what we said in the objective when I talked about using the discriminant. Because I will be organized. Oh, I never actually said it. I should have written down the objective, or just determine how many solutions it has by checking the discriminant, because I will be organized and follow the order of operations. All right. So now, when you're using the discriminant, basically, we're going to look to see what's in here. So let me give you a couple notes on it. Alright, so the discriminant is just the thing inside the square root. It's not really including the square root. It's just the b squared minus 4ac. That's called the discriminant. And in other words, when you're using the quadratic formula and you're putting along and you're doing your thing, if you get a positive number in here, well, we already talked about with that square root of 49 example back here, if you have the square root of 49, that's going to be two answers, positive and negative 7. So if you have a positive number in here, you're going to have two solutions. So let's write that down. So if you're discriminant, meaning the thing inside the square root, if it's a positive value, you'll have two solutions. Now, if it is 0, meaning if all of this in here equals 0 when you plug in for everything, meaning the square root of 0, well, hey, the square root of 0 is 0. That's one number. So if its discriminant is 0, you'll have one solution. And now, if this discriminant on the inside, if you plug in here and you get a negative value, You can't take the square root of a negative. Nothing times itself equals a negative. It doesn't exist. You'll talk about that in Algebra 2 when you talk about imaginary numbers. But for our purposes, it is true. It doesn't exist. It's not a real number. It's imaginary. But you don't need to know that. So basically, it has no solutions, meaning it has zero solutions. Technically, it's zero real solutions, but don't overthink it. I'm sorry for mentioning the complicated way of doing it. You won't need to know that until next year. But basically, if it's a negative value in here, you have zero real solutions, meaning it'll never cross the x-axis. This one will cross the x-axis once. This one will cross the x-axis twice. So I'm now going to do some examples of those. But if a question just simply wants to know how many solutions does it have, all you've got to do is just b squared minus 4ac. You didn't have to do the whole formula. You could have just done that part and checked it that way. But it also helps you know what to expect when you're working your way through a question. So if a question says to solve this, start putting it in standard form. Or if it just simply says how many solutions does it have, you still got to put it in standard form so that you can check the discriminant, so you know what A, B, and C are. So I rewrote it in standard form, because if it's minus 16 over here, you move it by adding 16 to both sides, and that's why you notice it's positive 16 when it's on the left side. Alright, it's in standard form. So now you're ready to plug this into the quadratic formula. But again, if it just said how many solutions does it have, you would only need to do the b squared minus 4ac part. You would only do that. Plug in for b, a, and c, and check C positive, 0, or negative to tell you how many solutions. I'm going to mention that as I'm solving it, but I'm going to use the quadratic formula. So plug everything into its spot. Get everything ready and plug it in. Now, it's normally the opposite of b. Notice, b is negative 8, so the opposite of negative 8 is positive 8. But now when you plug it on the inside, it's got to be negative 8 again, because b is negative 8, and it says just regular b in there. It doesn't say opposite, so it's positive when you put it in there. All right, let's go ahead and plug in for a and c. Okay, now follow the order of operations on the inside. In other words, we're going to just look at the discriminant first, because that's what we've been doing anyways. We've been simplifying the inside of the square root first. 16 times 1 is 16. 16 times negative 4 is negative 64. Negative 8 squared, a negative times negative is a positive. That's positive 64. So we have 64 minus 64 in there. And your bottom is 2 times 1, that's just 2. Okay, so now you do the inside of the square root, 64 minus 64. Well, you already know that equals 0. So that tells you you're asking yourself for the square root of 0. And the square root of 0 is 0, meaning 0 times 0 is 0. No need for positive or negative, because 0 isn't positive or negative, it's neutral. So you're really just left with x equals 8 over 2. You don't have 2 questions to answer, you only have 1. So that's how you know you're only going to have one solution. Because when it's a 0 inside of here, you're left with only one thing to do. 8 divided by 2 is 4. Okay, so our solution is x equals 4. That's our only solution. We only had one. But if you notice inside of here, your parentheses, if you get a 0 in there, you already know to expect one solution, because the square root of 0 is 0. And 8 plus 0 is 8. 8 minus 0 is still 8. So you don't need to worry about that 0 if your discriminant turns out to be 0. Alright, so let's now see what happens when this example has no solutions. You're going to like this one, because there's not really much work to do after plugging it in. Alright, so start with the quadratic formula, plug everything into its spot. My personal preference is to get all my blank parentheses ready so that I remember to plug in with parentheses. Now the opposite of negative 9 is positive 9. But when you plug it in here, it's the regular b, which is negative 9. So then go ahead and plug in for everything else. Okay, now follow the order of operations on the inside. 22 times 1 is 22. 22 times negative 4 is negative 88. And then negative 9 squared is positive 81. So you have 81 minus 88. Oh, that might be negative. And the bottom is 2 times 1 is 2. By the way, for the past few examples, I keep being 1. I keep choosing things with a coefficient of 1. It doesn't matter if it's not a 1. It could be anything. It could be a 4. Have I really not done any where it's a 1? Okay, I did one where it wasn't a 1. Good. Just so you know, it's not always a 1 down there. It's not always 2 times 1. Anyway, go ahead and do 81 minus 88. And you'll notice when you do that, when you do 81 minus 88, you get 9 plus or minus, you get negative 7 over 2. And here's the thing, like, all right, I'm ready to go on to my next step. Except, if you go to your calculator and you type in negative 7 square root, you're going to get an error. It doesn't exist. It doesn't work. Nothing times itself equals a negative number, because a negative times a negative is a positive times a positive is a positive. You'll never have it equaling a square root of something being negative. I mean, yeah, so you can't take the square root of a negative number. It doesn't exist. So because of that, you're done. That's the best part. You have nothing left to do. You can go no further. Algebraically, it doesn't exist. Now, in Algebra 2 class, yeah, you learn how to go further, but we're not doing that. You're done here. So you're going to say no solutions, meaning this graph of this parabola, if you were to graph it, would never cross the x-axis. It just doesn't happen. So this tells you no solution. You get to stop right there. Sweet. Now, the only way to check yourself is just make sure you plugged in correctly, make sure you followed the order of operations correctly, and it really does equal a negative in there. So no solutions. You know that because your discriminant was negative. And that's the shortcut, but the explanation why is you can't take the square root of a negative. Alright guys, so this is the quadratic formula. I'm not going to fill this thing up with a ton of examples because it gets really repetitive. But here's the good news. We're going to come to class, we're going to practice this, we're going to be detail oriented. I'm going to be wearing my shirt that says keep calm, show your work. Because it's one of those things where it's almost like a recipe. And this is the method. Remember, it always works. That's the beauty of the quadratic formula. It's the one that always works. So out of all the methods, it may look more intimidating because it looks like there's a lot of writing, but really it's just the order of operations and working your way through and then solving both versions of the question so you can get your solutions. All right, let's practice this and we'll take it to the next level in class. Take care.